Hello and good morning. We're in week 7. Make sure you take a look at your grades, okay, because we're getting close to the end, okay? Anyway, every Friday, you have from Friday to Sunday to turn in your week's work. Make sure you're doing that and use Microsoft Lens. If you go to my videos, Toops' Classroom, you will see Microsoft Lens video that will help you. Also, how to upload the Canvas. So there's really every reason for you to be able to do it. So look up here. This is division, and we need to keep it, change it, and flip it. So keep, change, flip. So let's take a look here. First, we're going to do times 10 plus 1. So that's 11 over 5 divided by 3 over 1. So we're going to keep this, we're going to change this, and flip this. So it's going to be 11 over 5 times 1 over 3. So it's going to be multiplied straight across. This is not a proportion. So that becomes 11 over 15. See, the difference between this and a proportion like x over 4 equals 3 over 2, that's called a proportion, where it's equal and you do cross multiply. But here, you just multiply straight across. Okay, hopefully you understand that. Keep, change, flip. Too bad it's not KFC. Anyway, this one right here is subtraction. Now remember, for subtraction, you have to find the least common denominator. So this is 10 plus 1, so that's 11 over 5 minus 3 over 1. What you're going to do is take the 1 and put it over here, which isn't going to change anything. You're going to take the 5 and put it over here. So you get 11 over 5 minus 15 over 5. And now your denominators are the same, so you have more minuses. You have 4 more minuses, so it's going to be a negative 4 over 5. Make sure you understand how to do fractions. All right. What I want you to do now is go to page 132 in your book, and we're going to take a look at this page right here. Okay? I'm going to read it, and we're going to work it together. All right. These are motion problems from chapter 2. Here we go. Chicago and Green Bay are 200 miles apart. So we have Chicago and we have Green Bay, and there's 200 miles apart. So from here to here is 200 miles. You have, if a car leaves Chicago traveling at 55 miles per hour. So it's going this way at 55 miles per hour. Distance equals rate times time. Okay, so the rate is 55 here. And let's see what else. And at the same time, a truck leaves Green Bay. So it's the same time traveling at 45 miles per hour. When will they meet? When will they meet? Okay, well this one, let's figure out the distance of the car. So we have Chicago and we have Green Bay. So the distance for this one equals rate, which is 55, times the time. They left at the same time, so you're going to leave it as t. This one is going to be 45, as he's going slower, times the same time, okay, t. And what you want to do is set these equal to 200, and that's what they did here. Okay, so let's see where they got it. Okay, see right here how they have it? So it's 55t plus 45t is equal to 200. Then you combine like terms and work it out. And they did that for us. So 2 hours into the trip, they're going to be dead even with each other. Okay? They will meet in exactly 2 hours. And that's the first one where the cars are coming towards each other. Let's try another one. This one right here, you have two ships going in opposite directions. Okay, let's see what it says. And it might start over here. Okay, here it is. Two ships leave port, one heading at 12 miles per hour east. So we have north, south, east, and west. So one's going this way, heading east at 12 miles per hour. And the other one is heading west at 10 miles per hour. The question is, how long before they're 33 miles apart? Okay, so you want to go a total of 33 miles from here to here. So one is going this way and one is going this way. When will they be 33 miles apart? Now the question is, did they leave at the same time? Two ships leave port. Okay, so we assume they're leaving at the same time. So distance equals rate times time. So what we're going to do is the same idea. We're going to add up this one plus this one and set it equal to 33. So one of them is 12 miles per hour and the other one is 10. Okay, so one is 12 and one is 10. So we're going to say rate times time. So one of them is going to be 12 times t equals distance, and one of them is going to be 10 times t equals distance. And we're going to set them equal to 33. So it's going to be 12t plus 10t is equal to 33. So it's kind of the same idea as the first one. Okay, so that's the second type. And you can see they did exactly that on the problem. They added them up and set it equal to 33. All right, let's keep moving. All right, the next one now. The next one's a little different. Okay, it says a car leaves heading east. So this one's traveling east at 50 miles per hour. Okay, this is example 3. It's all in your book if you want to reread them. 1 hour later, a second car leaves heading east at 65. So an hour later, this guy is traveling faster, but it's an hour later. So you want to know when will the second car overcome the first car? Okay, so when will this guy catch up with him, basically? Okay, so now this one left at t. He has a jump. He has a 1 hour jump. So distance equals rate times time. So the times are not the same. Okay, so this guy right here, his distance, this first guy, is going to be 50 times t plus 1 because he has a 1 hour jump. Okay, the other guy, the distance is going to be 65 times t. Okay, so this guy's got a 1 hour jump. All right, so now let's take a look at it. Turn the page. Let's take a look at the equation. If you look at the equation, they're setting them equal to each other. Okay, we're not adding them up and setting them to a distance. So you're going to take the 50 times the t plus 1, because he has a 1 hour jump, is equal to 65t. That's when they're going to be dead heat, nose to nose. Okay, so this one, you set equal to each other, you distribute, and you work it out. And they did that for us, and it's 3 1/3 hours, 10 over 3. So like 3 hours and 33 minutes. Okay? All right, so if you understood all of that, let's keep moving. It looks like they changed it to minutes or something. Or they plugged it in. Anyway, let's go on. You might have to plug it in. This next one right here is a mixture problem, okay? And we'll take a look at the mixture problem tomorrow. So if you finish your work today, I want you to read over this example. All right, let's see what I want you to do today. The mixture problem is pretty good, actually, and so is the nuts is a mixture problem as well. So for today, I want you to try, let's try 1 through 21. So page 137, 1 through 21. Okay, that should take care of MCR. Let's get off of MCR. And at 9:10, we're doing geometry. So 9:10 is the time that geometry clicks in. All right, so let's take a look at geometry here. All right, first of all, on the EOC this Friday, it's a practice test. But remember, your parents are going to see your score in relationship to all my kids, okay? So we want to try to impress them. All right, let's take a look here. Name a line. Take a look at this right here. Remember, a line uses 2 points. 2 points. If you say line ABC, you're going to miss it. A line uses 2 points, okay? So you could say line AB. That's fine. You could say line, notice I have 2 arrows. You could say line BC. It's the same line. You could say line AC. And you can say that fancy L. You could say line L. Those are all the ways to name a line. You could go backwards. You could say BA or CA. I mean, there's a lot of ways to do it, but you cannot use 3 points. Memorize that. It's on the EOC. Also, name angle 1, number 2. This is angle 1, so it starts here, goes to B, and then it goes out this way. So it goes from here to here. So it starts at C. So for number 2, that's number 1, you would say angle CBD. It uses 3 points. That's called your vertex. The vertex is where it turns. Or you can go backwards. Angle B or DBC. Angle DBC. Make sure you can name an angle. Now you wouldn't say BCD because BCD would be BC and then it would go to D. It would be that angle right there. So be careful. Okay, you can't just say angle B on this one because it could be something different. Number 3, name angle 2. Well, angle 2 is here, so you could say ABD, angle ABD, or you can go backwards, DBA. And that's how you name an angle. Look at the next one, name opposite rays. Okay, number 4. An opposite ray starts at the same point, so one goes this way and one goes this way. So you would say ray BC and ray BA. Only 2 points here. So lines and rays only use 2 points. Angles use how many points? All right, let's keep moving. We had this yesterday. Let's talk about this. Well, what goes on top, the X's or the Y's? Well, we know the Y's go on top. Okay, it's kind of weird, but that's the way it is. So it's -2 and -4. Okay, and down here, it's going to be 5 and -2. Make sure you can do slope. This becomes a plus. So 4 minus 2 is 2, and this becomes a plus, and that gives me 7. Where I's overrun. Midpoint, you add up the X's. So add this up. 5 minus 2 is 3. And then you add up the Y's. That's a -6 divided by 2. So the midpoint here is going to be 1.5 or 1.5 and -3. That's your midpoint. Make sure you know how to do midpoint. Very easy. You divide by 2 because it's halfway. A midpoint is in the middle. This is equal to this. All right, distance. I remember the X's go in here. You have to memorize these formulas. Okay. All right, so I'm going to start with this one. So I'm going to say -2 and 5. Those are my X's. And -4 and -2. So this right here becomes a -7 squared. This becomes a plus, so that gives me a -2 squared. So that gives me 49 plus 4, which gives me the square root of 53. And then you use your calculator. Make sure you can use your calculator. Watch. 53 shift square root. I get 7.3 approximately. And that's how you do distance. Okay, we're not going to try to extract on that one because 53, I don't think, it might be a prime number. Again, we talked about the EOC. Let's talk about today's work. If you can't be with us today, there's the worksheet, and I'll upload it in a minute to Canvas. And here it is right here. Okay. And I'll try to send it on Canvas as well. Well, let's take a look at this one here. Okay, so let me get situated with my work right here. Remember, if you're working at home, to use best practices, okay? Close the door, sit at your desk, or wherever you work. All right, look here. List the points for the pre-image. So it's J, Q, H. So J, Q, and H. Okay? And then the next one is going to be J prime, Q prime, and H prime. Okay, we're doing rotations here. And here are the rules. Right here. Okay, so if you go on 90 degrees clockwise, what does that mean about the origin? So here's the origin. Okay. So the origin is the middle point there. So O-R-I-G-I-N, the origin. Okay. So if you go on clockwise, that's this way, okay, the way a clock moves, then you switch them and change the x. Write that down. Switch, change x. Okay, you got to memorize that. Well, let's do that. So the points here, J is going to be negative 1, 0, 1, 2, 3, 4, 5. So negative 5. And down 1, 2, 3. So down is a negative 3. So you switch them and change the x. So this one comes first, and you change the x to a positive. Okay. So this is now going to be negative 3 up 5. So negative 3 up 5. 1, 2, 3, 4, 5. Put J prime here. Okay, what we're doing is rotating it 90 degrees. All right, let's keep moving. The next one, Q, is over 0, down 1. This is a good chance for you to get your points, okay? Switch and change the x. Well, when we switch them, the negative 1 comes here, and you can't change 0. So that's going to be negative 1, 0. So this point actually stays the same. So this is also going to be Q prime. It seems awfully long. Let me look at it again. Over 0, down 1. Over 0, down 1. And the rule is switch and change the x. So I switch them. I move this one to the front, and I change 0, 0, you can't change. It just seems kind of long from here to here. Okay. Well, let's go to H and see. So H is 0, 1, 2, 3. So that's negative 3. And then this one is down 1, 2, 3, 4, 5. So down 5. You got to switch them and change the x. Okay, so switch, the negative 5 comes here, according to this, and then change the x. So this becomes a positive 3. So negative 5 up 3. 1, 2, 3, 4, 5. 1, 2, 3. This new point right here is going to be H prime. And so this one is going to look like this. Now it looks kind of long, so I would question that point right there. Everything else looks pretty good. This looks like a 90-degree rotation from here to here. We'll try another one, okay? But that point, maybe I did something wrong there. Let's try counterclockwise. Okay, so write down your points. So we have S, B, L, it looks like. So put S, B, L. I want to see the points. Okay. So S is over 2 up 2, so 2, 2. B is over 1, 2, 3, 4 up 1, 2, 3, 4, 5. So 4 and 5. And this one is 1, 2, 3, 4, 5 over 5 up 0. So we want to put the new points, the rotation, so put S prime, B prime, and L prime. And let's just follow the rules, okay? So let's look at the rules. So for this one, counterclockwise goes this way. Okay, so we want to go 90 degrees counterclockwise. So let's see how that would look. It's going to be somewhere over here. So 90 degrees about the origin. So 90 degrees counterclockwise, you switch them and change the Y. Okay, so switch. This one is the Y. I switch it and I change it. And this one stays the same. I switch it. This is my Y. I change the Y. And the X stays the same. I switch them and change the Y. You can't change 0 and the X stays the same according to this rule here. See how the X stays the same? That negative doesn't mean make it a negative. It means change. So if it is a negative, then you change it to a positive. Let's see what it looks like. So negative 2 up 2. So negative 2, 1, 2, up 2. That point is S prime. And then negative 5 up 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Put a point right there and call that B prime. And then finally over 0 up 5 it looks like. So 1, 2, 3, 4, 5. And the new one, or the image, should look something like this. And that one actually, I like that one. That one looks right. This one, not so much. All right, so anyhow, do your best. Here are the rules. If you get stuck, ask, okay? Now, there's something called 270. Let me show you that. Now, there's really, the way to think about it is like this. The whole circle is 360. So if you have a point here, and you want to go about the origin, and you want to go 270 And 270, let me think about this. 270 clockwise. Okay, so yeah, 270 clockwise would be like 3 turns, because this is 90, 90, and 90. That makes 270. So it'd be 1, 2, 3 clicks. Click, click, click. So what you do is, to get that, you would go 90 degrees counterclockwise. Now, I don't know if that makes sense to you, because if you go 90 degrees counterclockwise, it's the same as if you go 270 clockwise. I will give you the formulas for those, so let me look those up. But anyway, I think this is good enough for now, and have a good morning.